writing geometric equations. Okay, if you recall last week, we did those little bouncy ball problems. Okay, same kind of concept. Okay, but instead we'll be given a sequence like this. Okay, so when being asked to write an equation for a geometric sequence, okay, remember it's because we are multiplying between each term. We need to find two things, very similar to what we did with the arithmetic ones when we're adding between each term. We need to find the 0th term, okay, which is usually labeled a sub 0. Okay, and then we need to find what we call a generator. And all that is what are you multiplying by each time? Okay, so usually that is pretty straightforward. Okay, we go from 2 to 6 to 18. Okay, what are we multiplying by each time? Should be 3. All right, because 2 times 3 is 6, 6 times 3 is 18. Okay, so we're multiplying by 3 as we go to the right. Okay, similar to our arithmetic equation, we need to find what would come before 2. Okay, so again, if we're multiplying by 3 going to the right, what are we doing going to the left? We are dividing by 3. Sometimes it'll be a nice number, sometimes it'll be a fraction. In this case, it's 2 divided by 3. So we'll just write 2/3. So the equation we use for geometric sequences is written like so. T of n equals a sub 0 times r raised to the nth power. So our equation for this, T of n equals a sub 0 is 2/3. Our generator, or our multiplier, it's also called sometimes, is 3. And we raise it to the nth power. All right, another one, 2, 8, 32. Okay, we're multiplying by 4. So that'll be our R value. Work backwards to find our 0th term. We divide by 4. So we get 2 divided by 4, or just 1/2. So we get T of n equals 1/2 times 4 raised to the nth power. All right. So here it's a little tricky. Okay. So what's really important to remember with geometric sequences, okay, we're always trying to figure out what are we multiplying by to get to the next term. Okay. The easiest way to look at this is, okay, how would I go from 36 to 9? What would be your initial reaction, Calvin? Okay, subtraction would be your first guess, right? We'd subtract 27, okay, but 9 minus 27, we wouldn't get 9/4. So how else can we go from 36 to 9? Divide by what? 4, right? So usually the most common way to look at it is try and think of 36 divided by 4 gives you 9, but we don't want to think about it in terms of division, okay? So remember, dividing by 4 is the same thing as multiplying by 1/4, okay? And we want to use that. Okay, so it's always in terms of what are we multiplying by? Okay, and as we work backwards, instead of multiplying by 1/4, we're dividing by 1/4, which is really multiplying by 4. So we get 144, I believe. 36 times 4 will give you 144. So our equation would then be T of n equals 144 times 1/4 raised to the nth power. Okay, try these two on your own. All right, so on the first one, what are we multiplying by each time? 5. So we got to work backwards. 1 divided by 5, we'll just call it 1/5. So we get 1/5 times 5 raised to the nth power. Okay, second one a little trickier. How do we go from 15 to 5? What are we multiplying by? Okay, well, we could be subtracting 10, but then that doesn't get us to the next term. Okay, we could also divide by 3, that would get us the next term. So it's the same as dividing by 3, multiplying by 1/3. Okay, work backwards. 15 multiplied by 3 then would give you 45. So we get a sub 0 is 45 times 1/3 raised to the nth power. All right, so the other thing we could do is obviously find a specific term number. Okay, very simple, straightforward, just like we were doing the arithmetic one. So if we're given an equation or a sequence, let's go 7, 14, 28. Okay, and let's say we want to find t of 9. Okay, we write our equation just like we normally would. Okay, we are multiplying by 2 between each term. Divide by 2 to get the term before 7, which would just be 7/2. So we have t of n equals 7/2 times 2 raised to the nth power. If we want to find t of 9, then we're just plugging in 9 for n. And we get 1792. Obviously, you would need a calculator for that. I don't expect you to be able to do that on your own. All right, not super complicated if you can write the equation. And you try a couple on your own, keep practicing being able to write equations. Okay, try those on your own. Okay. So the first one, 10, 20, 40. What are we doing between each term? Multiplying by 2. So we divide by 2 to get our 0th term. In this case would be 5. So t of n equals 5 times 2 to the nth power. Find the 11th term by plugging in 11 for n. If you are using a calculator, or if you're using your phone, oops. okay? If you're using your phone, you have to do the exponent first and then multiply by 5. So you'd say 2, xy 11, and then you'd multiply that by 5. So you get 10,240. If you tried doing it the other way, where you tried saying 5 times 2 to the 11th, well, that still worked. If you said 5 times 2, and then you rose that to the 11th, okay, you'd get a really big number. Okay, so just make sure you're doing the exponent first. Okay, second one, again, we're decreasing, so our generator should be a fraction. Okay, we go from 30 to 15, should be multiplying by 1/2. Multiply by 2, okay, to get our 0th term, in this case 60. So T of n equals 60 times 1/2 raised to the nth power. Okay, so to find the 7th term, we should get 0.46875. If you had one of these big fancy calculators and you wanted to do that, okay, let me do this. Okay, there is a cool feature if you go to math and you go to fraction, it just takes that answer it gave you and turns it into a fraction. So 15 over 32 is the same thing. Okay, obviously I wouldn't expect you to be able to do that. I'm just kind of showing you how that works on these calculators. Some of the smaller ones are able to do that as well. Okay, just converting it from a decimal into a fraction. So, but either one of those answers would be acceptable. And same thing with the arithmetic ones. Could you just keep writing this out and find the 11th term? Sure, you could. I don't think it'd be too difficult. Okay, you could definitely screw it up at some point, but you know, back against the wall on a test of some sort, okay, and the number's not too big, okay, 11, 7, it's not that bad.